In this video, we're going to take a look at radical equations, and we'll look at two specific examples. First, we have one example where we have two radicals in it, and another example here where we have a fractional power, which we should know is the same as a square root, or a cube root in this case. And let's see how this works out. Here we have two radicals on the same side, and we might be tempted to go ahead and start by squaring both sides and say, well, maybe that will get rid of the square root. Well, real quickly, let me show you why this won't work. Let's say we have the square root of a minus the square root of b. If we square both sides here, well, that's like the square root of a minus the square root of b times the square root of a minus the square root of b. And square root of a times square root of a is a. We get minus square root of a times the square root of b minus the square root of a times the square root of b plus b. Now, these square roots did not go away, and our whole goal here is to make the square roots go away. So this just kind of makes things messier. So we're going to get rid of this and try a different method. What we want to do here is we want to get one radical all by itself. So let's move this one to the other side by adding, and then we can deal with it. So we're going to add the square root of x minus 3 to both sides. Here we have an equivalent equation. We've just added the square root of x minus 3 to both sides. And here we go. Now if we square it, what happens is this square root on the left side is going to go away, and that's nice. We're still going to have a square root over here, but we can deal with that in a minute. So we have x plus 5 because the squaring gets rid of the square root. Here, it's going to be helpful to remember something that we hopefully learned in a previous algebra class, and that's this: a plus b squared. Well, a plus b squared is a plus b times a plus b, which gives us a squared plus ab plus, multiplying the middle two, ab, multiplying the last two, b squared. And that simplifies to a squared plus 2ab plus b squared. Okay? So that's going to be a useful thing to use. And so what that means here is we have, this is our A, this is our B. Now if we write this out, this means 2 plus the square root of x minus 3 times 2 plus the square root of x minus 3. All right, and we'll go ahead and multiply this out longhand, but this is a step that as you practice, you'll want to skip, just because it makes life easier. 2 times 2 is 4. 2 times x minus 3, square root of it, is going to be 2. Square root of x minus 3. 2 times the square root of x minus 3 in the middle. And multiplying these last ones, the square roots will go away. And we get x minus, not plus, x minus 3. So we see that we had a, if this is our a and this is our b, when we squared this thing, we get the first thing squared, the 2 became 4. We have 2 of the ABs, 2 of these things multiplied together. There they are. And we have this thing squared, which just takes away the square root. And so in the end, we have 4 and these two guys added together will be 2 times 2 squared of x minus 3, which would be 4 x minus 3 plus x minus 3. And on this side, we have x plus 5. All right, so just keep thinking about that. If you understand this, then we can skip right from there to here. All right, so now let's get this radical all by itself, because we still have some radical left, but we get everything over to this side, and we can square it. All right, so let's clean it up a little bit more. We have this 4 minus 3, which is 1, plus x plus 4, square root of x minus 3. So if we subtract 1 and subtract x, well, those x's go away nicely, and we have 4 equals 4 root x minus 3. Let's divide it by 4, and 1 equals the square root of x minus 3. Now we're ready to square this, and it'll go away nicely. Square that, and we're left with 1 equals x minus 3. We squared the 1, but 1 squared is 1 here, okay? And adding 3 to both sides, we've got x equals 4. When you're working with radical equations, you want to plug that back in to make sure that's a solution that works. So we plug it in here, we get 4 plus 5, which is the square root of 9, minus, plug it in here, we get 4 minus 3, which is 1, so the square root of 1. The question is that equal 2? Yeah, 3 minus 1 equals 2. Checks out. So again, when you have two radicals in an equation, get one all by itself and square it, and then get the other by itself and square it, and finish it from there. Now those methods that we've seen so far, they'll work with square roots, cube roots, fourth roots, whatever, as long as you have the same radical in the equation. And we can also deal with these fractional exponents. If you want, you can change this to a cube root right away. But let's go ahead and leave it as a 1/3 power, because we got some real nice power rules that will help us here. Let's get that 3 to both sides, subtract 3 from both sides. Move it over to the other side. And now let's ask ourselves, what can we do to make this exponent go away? Don't try distributing that or anything. It doesn't distribute. It's an exponent. So what we need to do is we need to raise this to a power to make that go away. And what we can do is we can raise it to exactly the 3rd power, whatever that denominator is. All right, or more specifically, be the reciprocal. But we're going to do the same thing to both sides, raise to the 3rd power, and we have 1/3 times 3, because power to power we multiply. 1/3 times 3 is 1, so this is 2x minus 3 to the 1st power, but that 1st power doesn't matter, doesn't change anything, and negative 3 to the 3rd is negative 27. And it's all downhill from there. Add 3, negative 24, divide by 2, and x is negative 12. There it is. We can plug it in there. We get 2 times negative 12 minus 3 to the 1/3 power plus 3 equals 0. So this is 2 times negative 12 is negative 24 minus 3 is negative 27. So this is negative 27 to the 1/3. And that's just negative 3 plus 3 equals 0, and that checks out. All right, so negative 12 works. We got it. So just raise it to the power of the denominator there, or the reciprocal more specifically, and that fractional power goes away. And there you have your rational exponents and radical equations.